1 minute we will start, okay?
No problem, no problem.
Actually, our team is starting the YouTube streaming. That's why just waiting. A very, very warm invitation and good afternoon to all of you. By the grace of Sri Ramakrishna, Srima and Swami Vivekananda, we are on the verge of completion of our first week's schedule. And today we got a very, very able speaker, Professor Umesh Kulsreshto, Professor Dr. Umesh Kulsreshto, the Dean of School of Environmental Sciences, Jawaharlal Nehru University, India. He is a fellow of Indian Geophysical Union and presently the Deputy Director of South Asian Nitrogen Center, New Delhi. He is an assessor of National Assessment and Accreditation Council, NAC. He is a member of the Advisory Committee of Knowledge and Awareness Mapping Platform, a knowledge alliance with CSIR, National Institute of Science, Technology and Developmental Studies. He is the Vice President of Society for Conservation of Nature. He is the Editor-in-Chief of Board of current World Environmental Journal. He is the member of editorial board of Aerosol and Air Quality Research Journal. He has got innumerable awards. The START Young Scientist Award by IGBP START USA, Thomas Kuhn Honor Pin by International Academy of Sciences, CSIR Young Scientist Award, MS Krishnan Gold Medal by Indian Geophysical Union. He has published more than 100 journal papers and 5 books. He has made significant contribution towards atmospheric chemistry, air pollution, and climate change research. He has been a member of the Environmental Pollution Control Authority, a regulatory body under Supreme Court of India, EIA Accreditation Committee of NABET, Quality Council of India. He was the Director Transdisciplinary Research Cluster at Jawaharlal Nehru University. So very, very able speaker, but above all, he is a very sincere and very meticulous teacher, followed everything very meticulously. And that is why he is loved by everyone. So such a luminary, but just when I requested, so within few hours, he has accepted our request. We are very grateful, and all the participants, and including myself, we would feel very blessed. That is my hope, to have his lecture. Professor Kulshrestha, please, he will speak on air pollution. Please.
Thank you, Swamiji, for your very enlightening introduction, encouraging words. Can you enable my sharing?
Yes, it has been enabled, sir. Sir, it has been enabled.
Okay. No, it says host has disabled. It is not enabled.
Just a minute. Let me check one.
Hmm.
Let me check once. Yes.
Hmm.
Just you check. Yes.
Now I think it is. Yes. Are you able to see now my slides?
Yes. Yes. Yes.
Good. And I would like to add that I think this is my second time to this organization, Swamiji, isn't it? Because I think 10 years back, similar
Yes.
organization probably I came.
Yes. Yes. Probably. Yes.
I think so. So uh, I would like to speak about air pollution as requested because the participants are having some course, isn't it? So I have a blending with pure syllabus and research result. I have basically made this lecture to give you benefit of regional science. Basically, when regional science comes, it is not seen in regular books. So I will try to put those points before you so that whenever you uh, happen to be part of air pollution related some issues or allied topics, you would come to know the essence of basically that chapter here, and later on you can correlate with your thoughts and mechanism, whatever the results you are reading in newspaper, doing some research or analysis of a policy, something you are doing. So with this, I just want to now go to other slide. And once again, I thank Swamiji and the organization to invite me, and I'm glad that I am sharing with the students who are really curious to get education with this online course. Now, before going into details of uh, air pollution, we have to understand what is air. Many of you may be knowing because we are reading from primary level about air composition, and also air pollution. What we are not basically reading the advancement of syllabus and also advanced research
Professor, Professor,
about.
you can make it in the full screen view. Then it would be more easily visible. It is visible, but
I think if I make this,
full.
see, I have clicked that one. Yeah.
Oh, yes, yes, this one. Yes,
Hmm.
yes. Go ahead with this. Thank you. Thank
So
you.
so let us see what is air. As you see on the screen, uh, a table and a pie chart. Table basically gives the ingredients of air, constituents of air, what we breathe. You can see all the gases are there. Means in natural atmosphere also we have sulfur dioxide, we have nitrogen oxide, all even uh, carbon dioxide. So having these gases in the air is not the pollution. And moreover, the atmosphere is composed of four major gases: nitrogen, oxygen, argon, and carbon dioxide. So carbon dioxide, is a part of atmosphere. 33, 30 basically ppm, or you can say now it's a 400 ppm. It's a part of atmosphere. So CO2 is not a problem, but increasing concentration of CO2 are really problem, because don't confuse with many times uh, people think these things are not in air and now increasing. No, it's now added. It's not everything is there in air, all gases mostly, but their levels are increasing day by day due to anthropogenic activities, especially the fossil fuel combustion. So now coming to air pollution. What is air pollution? Now you know air. So the required level, if it is exceeding in the atmosphere and it is harming, that is the pollution. So the complete definition of air pollution is atmospheric condition in which substances are present at concentrations higher than their normal ambient level to produce significant effect on humans, animals, and vegetation or material. See, here in this definition, material is very important because human and animal, they have tendency to adapt. So it's sometimes very difficult to judge whether air pollution is really is there or affecting the living thing. But materials are really indicator where even they don't have adaptation. So, for example, if you are seeing corrosion, definitely sulfur dioxide or any other things are acidic things are there, or highly alkaline things are there where, which are creating corrosion. So this definition is considered as a complete. Then with this, now you can guess even very high levels of dust, very high levels of natural dust, that also comes under pollution. But today what we talk about pollution is mostly related to anthropogenic pollution. Anthropogenic pollution basically is related to mining and metallurgy. You know, you have to be very clear. The air pollution is topic of air, but the source is on the ground, earth. If you don't mine, you don't go for metallurgy, don't dig out the petroleum, you won't have this anthropogenic pollution. So what it does changes the cycles of carbon, cycle of sulfur, nitrogen, phosphorus, calcium, mineral or metals. So the thing is the anthropogenic activities when they are having combustion, then they emit basically all type of oxides because atmosphere is full of oxygen. So anything if you combustion is itself require oxygen. So oxides are emitted and further stable oxides are formed, and that way atmosphere phenomena. So it's emission, transport, transformation, and deposition. The four things are part of air pollution. Now what happens? The pollution, I will tell you the what are the sources, what are the what types of pollutants, and then what are the mechanism, a little bit about methodology, then coming to some examples which are really we have done research of that. Now as I told, the levels of pollutants higher than the required, and the level they have significant effects. Now, for example, we have in India, in Delhi, we have here high particulate matter. High particulate matter in Delhi, always you may be reading news about the air quality is poor, severe in Delhi. All these things are related to basically PM10 and PM 2.5 levels, and they cross most of the times in India, especially North India, because North India is a lot of dust is there, dust component, and also the construction activities, they also add to high level of PM10 and 2.5. Then if you say, for example, ozone pollution, we have high ozone pollution in Europe, America, because of basically lot of NOx and precursors, volatile organic carbon. They have the form ozone. Their dust pollution is not there, particulate pollution is not much there, but in India we have. Then we have a very high sea salt problem in coastal areas, because coastal areas we have a lot of sea salt, because of sea breeze. Then high ammonia, we have the problem of air pollution of ammonia in the areas where sanitation is the problem. And then we have nitric oxide very high in urban areas. Ratio to NO and upon NO2 is recorded very high due to transport. Automobiles, they emit lot of NO, and that is converted to NO2. So NO due to transport is always higher in urban areas as compared to rural areas. Then we have high SO2 in areas where thermal power plants are, like Talchar areas or that areas in India. But high sulfur dioxide was the problem in Europe, North America, then China, because of lot of fossil fuel consumption, and they suffered with acid rain. Acid rain means pH below 5.6, so that was the problem. Still problem is there, but it is improving. The acidity is decreasing, and little more means because they have target to cut down sulfur and nitrogen emissions, and their policies are favorable. They could able to do that. So there is improvement in pH of rainwater in Europe and North America. But in India we don't have problem. I will tell you why we don't have problem of acid rain. And if you look at this right side map, the map shows high dust areas, starting from Africa to India to Gobi Desert in China. This region is high dust region, whereas if you see this below map, the ozone levels are basically very high, higher than their recommended limits, the red one, and these. So this shows that tropospheric ozone is the problem in these areas. So this we have to understand that no, if you see this, and none of these basically areas in northern hemisphere are practically clean. They have uh, one type of air pollution or other type of pollution in different areas. So because human nature is to use energy, and energy basically still we are dependent on not very clean energy. Coal and petroleum, they are not clean energies. So this is the reason we are facing the problem of air pollution. And then also CO2 is not considered air pollutant, but it is considered a greenhouse gas. It is the part of climate change basically issue, but it's a major product of coal combustion and petroleum burning. Now, coming to sources of air pollution, uh, there are different categories. How do you class sources of air pollution? Basically, if you say one category, we can say natural and anthropogenic sources. Another category, when we say about the point and non-point sources. Then other category we can say mobile sources and stationary sources. And third one is scale wise, that local sources, local scale, regional scale, and global scale sources. So this kind of means you may not be confused. You should not feel any kind of ambiguity when it comes to somebody says point and non-point, because this is another category. This is another category. How do you classify what is the purpose of your categorization? That depends on different types of pollution sources. And if you look at these natural sources basically they have sea spray, as I mentioned, a volcanic eruption, that like Fog here, volcanic eruption, the uh, smoke, we call it fog, and then it's soil dust and wind erosion. This is also natural source. Lightning, that is also natural source, and forest fire natural. When it comes to anthropogenic sources, we have fossil fuel combustion, petrol, diesel, gas, coal. All these things are fossil fuel and anthropogenic category. Biomass burning, which is very common in Asia, even Africa. And then we have biomass burning is anthropogenic source and significant contributor of carbon aerosols. Then agriculture, we have it's a, we are now having nitrogen issue, nitrogen cycle change, that is very much related to fertilizer use, and also that agriculture also related to crop ready to burning problem, again air pollution. So it's a uh, multi is type of polluter, basically agriculture activity. And these things basically one by one, you see one thing, that issues are brought not all at a time, but one by one. We were having problem of, in the beginning, first problem of acid rain, that was identified due to coal burning, SO2, high NO2, and their oxide, basically then acid, as sulfuric acid and nitric acid. Later on, problem came of global warming, and then global warming was also linked with fossil fuel burning, and then climate change, and then ozone depletion, ozone layer depletion, then atmospheric brown cloud problem came. So all these things, slowly they are part of understanding of atmosphere, and also make going up to from local to global scale understanding of particular pollution, where sulfate, how, what happened, as you know. So these sources, basically natural or anthropogenic, they contribute both, but significant amount during past century has been contributed by anthropogenic activities. Out of that, we industries, and we have a lot of automobiles, transport, then agriculture activity, and biomass burning. In cooking in India, we have a lot of, in Asia whole, we have still practice of uh, चूल्हा चूल्हा पे रोटी बनाने का जो still we have रिवाज. So from that tradition, we have to now shift to non-polluting device, maybe LPG or electric. This not only this is air pollution for climate and uh, basically uh, other problem ecology, but it's a human health is more problem. We have done, my couple of students have done this kind of work, indoor air pollution related to this. So this is very significant. Basically, these four sources are very significant anthropogenic sources which contribute to air pollution, whether it is a gas, particulate, or type. Now, other category of sources, as I told, point sources, non-point sources, stationary sources, and mobile sources. If you see the point source, basically these are factories. Line sources, these are basically the automobile going on road from highways. All these are line sources. Then other one is non-point sources. If you look at the dust storm which comes during Aandhi, Tufan, that they carry a lot of dust, the pollutant, that is non-point source. As similarly, runoff water. Water, in case of water, if you say runoff water, that is also non-point source. Same way, if you have a yard, big yard, rail yard, aircraft, the airport yard, all these things, they are non-point sources. And again, another category in terms of their mobility. One is stationary and other is mobile. For example, factories, all the thermal power plant, they are stationary sources, whereas this aircraft and ship movement, these are mobile sources. This is basic knowledge you should have in air pollution. Then coming to natural sources, mostly as I told, sea salt, volcanic eruption, and lightning. These are basically considered, but almost the contribution to sulfur nitrogen cycle of these sources is only 25% around. The rest of these mostly contributed 75% around, contributed by anthropogenic sources. Now coming to natural sources, sea salt is basically around 3.5% salt is there in that TDS. So it's a huge uh, sodium chloride content in seawater. It has sulfur, calcium, potassium, and carbon. How sea spray is formed, little bit I will tell you. Sea spray is formed by two mechanism. One mechanism is coming from the sea spray with droplets, and the droplets, as you maybe seeing, you are from Calcutta, Kolkata, so mostly you know the sea behavior, the caps you see. And this one first mechanism basically it gives whenever the tides are there, you can see these caps, and these, if you are nearby these caps, generally you get wet, and that gives not only water, it has a lot of sea salt, and you can taste it with your hand skin. And other mechanism, this gives coarse particle in the air, but other mechanism is second one, that is rupturing out bubbles. Inside we have lot of biota. Biota emit lot of gases like DMS, ammonia, H2S. That gas comes out in as a bubble, in a bubble, then bubble reaches the surface of sea surface, seawater surface, and then it comes out like this. It ruptures like two eggs, and then it ruptures and it becomes opposite, and like that droplet which was this side, and it becomes other side, and then it releases gas as well as the fine particle. So the rupturing of uh, the bubble is a mechanism which gives you fine sea salt particles, whereas the spray gives coarser particles. Same way, volcanic air pollution. And we have, this example is there, Cotopaxi near capital of Ecuador happened in 2015. I just want to highlight here that not all the volcanoes having same kind of emission, same temperature. Here, three examples I have plotted in table, and they, one uh, Kilauea Summit, then other one Eta, LA, and Momoto. These are famous examples, and these having dominance of different gases. Temperature also vary from 820 to 11. So it depends. Many times, people think that all volcanoes they are rich in SO2. It's not the case, but definitely mostly they have CO2 and H2O2 common. Then lightning, which is considered, a very old phenomena happening in the atmosphere, contributing, and this ozone and NO2 dissociating NO2 ozone like that. So these are the reactions happen. Millions of lightning strikes happen every day around the globe, but the significant one are counted. And the air temperature can range from 8,030 degree Celsius during lightning. So this is uh, 8,030,000 degrees Celsius temperature. All the bonds are broken, and that's why this oxygen, nitrogen, they will react and form new compound. And again, these bonds are, so it's a chain reaction ongoing happens, and that's why we get natural NO2, and then further ozone, and that also gives some part of nitrate after further oxidation. Then other thing is, we should know what are air pollutants, types of air pollutants. Same similar to that types of sources, we can categorize it. for the purpose. There are four types. One is primary sources and secondary sources. Then second one is uh, primary pollutants and secondary pollutants. And then second one is gaseous pollutant and particles. Then criteria pollutants and non-criteria pollutants, local pollutants and transported pollutants. These categories basically you will find in terms of when you talk about transformation, primary and secondary pollution, when you emission, the gases and particle, like when you talk about air quality, then criteria thing comes, and when you talk about the transboundary and their transport, the local versus transported, you have to consider. Now, for example, gaseous pollutants, you have sulfur dioxide, you have nitrogen oxide, nitrogen dioxide, nitric oxide, carbon monoxide, ammonia, and ozone. Then particulates, for example, you have carbon soot, dust, ammonium sulfate, ammonium nitrate, all these are particles, gypsum, sometime in mining areas like that. Most importantly, what matters is directly emitting particles. Mm, Directly emitted pollutants are called primary pollutants, and then these are basically, as I told, what should be the primary which is coming. For example, primary source, if it is coming from sulfur, sulfur is combustion of sulfur in oxygen gives sulfur dioxide. And I even sometime in thermal power plant it gives sulfur trioxide also. Then particulate matter, we have PM10, PM2.5, PM1, whatever. Then nitrogen oxide, VOC, volatile organic compounds. You know, volatile organic compounds are basically everywhere, but uh, and these all these things when you are burning high density fuels, that also gives. Then metals like lead, these are primary pollutants. Then it comes to secondary pollutants. Secondary pollutants basically are the pollutants which are formed by the primary, like ozone. Ozone is formed by oxygen, and that's why ozone is always secondary pollutant. There are uh, some mm, point you should know that always primary pollutant, always secondary pollutant, sometime primary and sometimes secondary, like that. If you say so, for example, ozone is always secondary pollutant, SO2 always primary pollutant, then NO2 sometime primary, sometime secondary, because NO, nitric oxide, also gives NO2. So this type of confusion you should not have. Then air pollution in urban and industrial areas is often called smoke, that is secondary pollutant. Photochemical smoke is produced with the sunlight and NO2 and this, so PAN, they are formed, that sometimes gives irritation in eyes. So health problem is there. You might have seen in 2017 in Delhi also, a lot of eye burning was there due to crop residue burning that time. Later on, now things are improved. So when high pollution is there regarding NOx, VOC, and other pollutants, we give, I mean, some kind of health problem is seen. Similarly, Diwali occasion, we have lot of uh, cracker burning, and because of that we get a lot of particles and also heavy metals. And it is seen that next day after Diwali, and mostly we see a lot of children going to hospital because of running nose and getting allergy and fever, that kind of problem. So this is all about pollutant. Now coming to another uh, criteria and non-criteria pollutants, as you know, from air quality point of view, we need to have some kind of the criteria to define this particular pollutant is having this limit. Beyond that, basically it is toxic. From that angle, these 12 mm, parameters have been defined as national ambient air quality standard, because these have been tested against toxicological and epidemiological studies, and they found their limits are defined. You can see in CPCB website what these are: the respirable suspended particulate matter 2.5, carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, ammonia, lead, nickel, arsenic, benzene, benzopyrene. These are 12 criteria pollutant, but non-criteria pollutant which we have will mostly be studied for research purpose, that is volatile organic compound, polyaromatic hydrocarbon, and for acetyl nitrate, toxic metal. And I tell you, these cannot be criteria pollutant. Criteria can be made only for individual, and these are group. Basically, VOC is a group of element, pH group. So individually, if you want, then only criteria pollutant can be they can be given criteria. Their limit can be defined, and accordingly, you can have this regulation. All Central Pollution Control Board and even uh, EPCA, NGT, they follow the limits defined, and for these 12 parameters. So these are criteria pollutant, very much important for air quality management. Then how these air pollutants basically are controlled? Air pollution control mechanism basically depends on type of pollutant. For example, if you have particle pollutant, these are the devices, and if you have gaseous device pollution, that is tackled in different way. General methods of particle collection or controlling. These are basically gravity settling, centrifugal impaction, diffusion, inertial impaction, and direct interception, and also the electrostatic effect. Now look at this. Basically, if you, the philosophy is that if particle is heavy, it will settle through sedimentation. Particle is medium size, basically, then it will go to impaction. If it is very small, then diffusion. So from that angle, if it is settling chamber, you have gravity, and then the particle are coarser particle which are coming out from the industry. They are settled like this, and then if you look at this is interception. Interception means when it is particle moving, and but it is hits other by sidewise, and then because of that it is settled. But when it is directly hitting, this is called impaction. But when it is moving just like that, free and settling, that is diffusion. And when it is uh, basically filterable through sieve, we use sieve for removing different size of particle. So this is basically these are the mechanism, basically techniques used to collect and control particulate pollution from the industry source. Then these are general method for controlling gaseous pollutants. Mostly we have sulfur dioxide and nitrogen oxide problem. So, or if you look at this, how to control or uh, basically not to go for more SO2 emission, uh, we have to have change of fuel from low high sulfur to low sulfur. That is what we are doing now in this all Bharat Standard 6. Uh, from beginning to now, we are very less sulfur fuel, diesel basically. So if you are opting natural gas, liquefied uh, natural gas, low sulfur oil, and low sulfur coal, then definitely you will have less SO2 emissions. Also, you can use the desulfuride coal and oil. That is also means many places things are used. Then one option is you increase the effective stack height by and build tall stacks, redistribution of stack gas velocity profile, and also modification of plume buoyancy. You can definitely then dispersion will be more, and that the net levels at particular point will be less for SO2. And also you can use FGD, flue gas desulfurization system. That also what is very costly. So people are not using that one. Now the NOx is another problem. NOx basically you can reduce NOx uh, by fuel denitrogenation, and also you can reduce NOx by modifying combustion process, like happens in different type of engines. You are saying that one company is claiming that is also modification of combustion chamber. Then modification of operating condition, that you can do, whatever you are taking some mixture in the cupola furnace or whatever, then you can do that. And then there are other thing you can do with that. Basically NOx coming from transport tail end control equipment, you can do the selective catalytic reduction, then non-catalytic reduction, elective beam radiation, and stage combustion. These are all advanced techniques. You basically, if you feel, you can refer um, the literature, but this is at a glance. You can reduce SO2, but basically these all things are in practice, depending upon the industry and also the state. Mostly costly things are not very much used, but general things are moderate cost economic. They are in practice. So another thing is the pollution. Once it is emitted, now you know the what type of pollution. Then another thing is that which is affecting your air quality, that is the stability of the atmosphere, meteorology of the atmosphere, and how stable it is. If it is more stable, then dispersion will be less, and you will feel more bad, worse air quality. If dispersion is high, ambient concentration will be less, and once it is less, it will be transported somewhere. Basically solar radiation basically help uh, to disperse the pollution. It gives heat, like sun. Now this is called pillow effect. Pillow effect, when sun rays are coming and then they are hitting at a time, one fourth of earth is hit by sun. you know it's a round earth. At a time, one fourth takes, receive that radiation. Then that radiation basically heats the air parcel. Air is heated, so it pushes further and it goes. So other uh, part of air is pushed, and that is how sun is the triggering force of air movement. Whole air. If there is no sun, then air won't move because there won't be any pushing extra heat to the atmosphere, and that there won't be any pushing, and that is the dynamics of the system. So sun is the source of whole air dynamics. So stability depends on and day and night, and also the season wise. From morning to evening, stability classes changes from, you see here, A, B, and daytime ABC, but nighttime you have E and F. These are the classes. When wind is like 2 to 3 and 3 to 5, like you can see here, low wind, high wind, nighttime, daytime. So this version depends on that. And also this is basically when it goes to horizontally, but vertically also air moves, and but it has limitation. That you see left side, atmosphere is having four layers, depending upon the pressure, Earlier it was classified into troposphere, stratosphere, and then mesosphere and ionosphere. But now it is only based on temperature profile. So it is troposphere, stratosphere, mesosphere, and thermosphere. So this is dispersion, but we are talking today air pollution only in this range, only this very close to this line, uh, 10, 15, only around 1 kilometer. It's around, how much? 100 kilometer, more than 100 kilometer it is. So we are concerned air quality only on this line, 1 kilometer around in the troposphere, and even the very well below with the boundary layer. So this is affecting only a very small part of the atmosphere, but the consequences are too much on the Earth's surface, and that is what we are worried about. Climate change, uh, that is the related issue. And then uh, the important thing in atmosphere, vertical movement is lapse rate. Lapse rate is basically as you go up, if you see here, the temperature is going down, means here temperature going down means density is reducing. Most of the pollutants are near surface, and as you go up, their concentration become very less. So the density is less, friction is less, temperature goes down. Most of this high temperature is due to particles, which are near surface. So particles or gases are not much, so the temperature goes down. It is estimated three types. One is called environmental lapse rate. Other one is uh, diabatic lapse rate. Another one is saturated lapse rate. So normally we talk about environmental lapse rate, which is around 6.5 degree temperature cooling at 1 kilometer, and dry adiabatic lapse rate is around 9.5, but perfect is 10 kilometer, 10 degree per kilometer reduction. But when it is high humidity, saturated cloud, that is around 4.5 degree temperature cooling at 1 kilometer. So when we talk about normally, this is environmental lapse rate around 6.5 degree cooling at 1 kilometer. As you may be going, you might have traveled with the aircraft. As you go up, the aircraft is moving around tropopause, and that height is around in tropical region 10, 11 kilometer around. So that you may be seeing 11 in somewhere with some minus some temperature comes depending upon the season. That is, so this is something how the vertical movement of pollution and then horizontal movement of air pollution. Now coming to this, uh, what happens to these air pollutants coming out of natural sources, anthropogenic sources? As discussed, these are basically in terms of gases and particles. They give some problem, like very significant one, as I mentioned, ozone depletion, global warming, and acidification. These pollutants basically then, whatever you emit one day or other, it has to be settled on the earth, and basically that is for deposition process. And deposition happens by two processes. One is wet process, and other one is dry deposition process. Wet deposition process, basically we have, you might have seen rain, snow, and fog. It happens in three phases. And then when it rain is formed, clouds are formed, that is called in cloud scavenging of pollutant. And then when rain comes at a particular location, that phenomenon is called below cloud scavenging. And when dry deposition is there, when rain is not there, no fog is there, no hail is there, then no snow is there, that time also always pollutant they are removed, gases or particle all time it's a settling. That is called dry deposition. Gases are settled through dry deposition, but coarser particles they settle during non-wet condition, and that is called uh, dust fall deposition. So from that angle, let me tell you, dust fall is not common in Europe or North America. This is a unique feature of dusty region, as I showed you in the map, especially South Asian region. So dust fall is especially term. It, we should not confuse with dust fall with dry deposition. That if you read paper of dry deposition means that is the deposition taking place through diffusion and impaction. Dust fall is taking place through sedimentation. However, when dust fall is there and when gases are interacting, when moisture is there, that time the dry deposition of gas also gives, and I mean it will enhance. For example, sulfur dioxide is there and dust particle already settled, then SO2 will come down and settle. It will get adsorbed onto that. It will form sulfate. So from that angle, it is dust fall for the dust calcium component, but dry deposition is for sulfur dioxide component. So this is little different term here used. We should be aware of this. Then this is the fate. Now we will discuss two major pollutant. One is ozone and other one is dust. How much time is there? Still 1 hour is there. Okay. Now, as you know, that ozone is connected with ozone depleting substances, stratospheric ozone. It started with the observation of ozone hole over Antarctica and during spring season of the southern hemisphere. Let me tell you, northern hemisphere and southern hemisphere things are very different. When we have season winter, their season is summer. So when we talk about it happens during winter, means there it is summer. And photochemistry of summer is more vigorous than the photochemistry of winter. In southern hemisphere, the ozone hole was at that time onward. Regular measurements are going on around the globe, and to assess, vertical distribution of ozone, how it is, because ozone is found in the stratosphere. So there is, ground sources of surface ozone, but at the same time, stratospheric ozone is also uh, is also coming down. That is called ST exchange, stratosphere troposphere exchange. That also gives a little bit. Hilly areas are having, that's why more ozone, because they are that is deep some ozone, because ozone is heavier than air. It wants to come down. Anything heavier than air wants to settle. That's why similar way the cloud movement happened, because air parcel having cloud is having water is lighter than air, so it moves to fill that gap happens. For example, monsoon get, so there is a Indian region when it is heated, at that time the gap, the low pressure comes, means that low pressure is filled by the lighter thing, which is it comes very fast, and that is called monsoon. Monsoon happens because of this. So same way, ozone, this was going on, and this ozone ST takes place due to, but that is because for ozone formation is driven by photochemistry. So day and night things are there. So it's a short term, always ozone cycle is very short term, and that's why in national ambient air quality also Other pollutants are studied 24-hour average, but it is studied 8-hour day. So that way, you have to understand the difference of ozone. Now, coming to ozone properties, ozone is colorless gas. Uh, then it's always a secondary pollutant. Ozone is measured in terms of Dobson unit because there was a scientist who started uh, ozone measurement. Dobson unit basically normally we have in a column. This is from ground to up, column, air column. So around 300 Dobson unit ozone is there. And that 300 Dobson unit ozone, basically if you compress all ozone, this is only 3 mm thick standard pressure and temperature. So that way ozone is uh, very high in stratosphere, not in troposphere. Ozone depletion, when we talk about this is standard and define that when the ozone is less than 2/3, this is called depletion ozone. And if you look at this, shall I take break? Hello?
No, sir. You have assigned for 7 p.m.
Okay, so I will take 2 minute. I just
Okay, okay, sure, sir.
Hello? Are you able? Huh? Hello?
Yes, sir. Yes, sir. You are audible now.
Earlier, I think there was some, it was muted. Huh? So I was telling that ozone is of two types in terms of harmfulness, usefulness. Stratospheric ozone is called good ozone, and tropospheric ozone is called bad ozone. As a chemist, you know, ozone is ozone, O3. So bad and good is only in terms of its place. Stratospheric is good because it stops UV and protects us from the bad effects. In troposphere, that UV is not there, but this is having another absorption in troposphere. It gives global warming, and also ozone is damaging plants, crop yield. There have been reports about the ozone. So that way, ozone is harmful in troposphere but useful in stratosphere. If you look at this tropospheric ozone and stratospheric ozone, but the concentration in troposphere of ozone is very, very less. But day by day, what we are seeing, ozone problem is increasing, especially in West. In India, we don't have still the problem of ozone, but recently in 2019 and 2020, that has been it has been reported that ozone is increasing, or spikes have been reported in Delhi and after COVID, most of the urban sites. If you see this, ozone is very high in these places, yeah. Europe, North America, China, and Thailand, that area, because this is the area where all these conditions met. In India, it is not very problematic. Now, coming to what is that? Stratospheric ozone is governed by a cycle called Chapman cycle. This cycle is three-step cycle. Initiation of ozone by oxygen that is photolyzed, and then atomic oxygen form, then propagation, the O react with oxygen, they form ozone, then termination. Ozone is again dissociated into oxygen, and that also, you know, these all are wavelength dependent. At particular wavelength, if it is lesser wavelength, splitting is different than if it is higher. So depending upon the wavelength means energy. So if it is lesser wavelength, nanometer, it's high energy. So from that angle, all splitting, the dissociated molecule atoms are different from different splitting. For example, you are having 175 nanometer oxygen molecule is dissociated in O1D and O3P. If it is 245 lower energy, then it is split O3P or 2O3P. And if it is very high energy, it is split at O3P and O1S, like that. All this depends on the energy. Now coming to tropospheric ozone, this is problematic ozone, and this is related to NOx and VOC. What happens in NOx and VOC? They react and form ozone through these reactions, including the methane is, you know, reacting like this and forming ozone and CO2. So this is kind of non-methane hydrocarbon chemistry comes into this. Now how this NO2 is formed? NO nitric oxide from NO2. Why two thing? Why two mechanism? One mechanism is called this one, 2NO plus O2. This basically occurs when NO is very high, like thermal power plants and vehicular tailpipe. This is the reaction happen. But normally In ambient air, NO is very less, and during that lower concentration, NO2 is formed by this HO2 and RO2 radical, and this basically is the mechanism. Recently earlier this was thought that this is the same thing happening with oxygen. This was not the case, and this is cycle how ozone and HO2 formation is governed. And this cycle basically it highlights there is a formation of HO2 through the hydroxide radical reaction with hydrogen peroxide, and then this goes further formation of this OH basically comes out, and then it gives nitric acid as a deposition. So this everything, whatever after reaction, everything goes down, whether homogeneous and heterogeneous. The settlements are there. These are called deposition or scavenging. So from this angle now, why I am saying we worked on ozone, because in Delhi in 19 May 2019 May, there were reports that ozone is higher, reported higher. When we saw data that time, I was in EPCA and I saw the data, and then chloride was also high, reported by somebody else. And here comes that that at some sites it was high and some site it was not. And because I was going to fields and looking at this, then I looked at data, and when this used common sense and then science, background science, our work, everything put together in a holistic manner, I just defined this ozone concentration recently seen in Delhi and even after COVID are higher, but those are really not higher. These are the background values of this Delhi area. Whatever area, urban areas you are seeing higher, these values are not higher. In most of these areas, industrial areas, urban areas, people are burning plastic burning. Then there is another source of chlorine and HCl is the pyrolysis oil coming from tire oil factory. Tire on the heat tire, and that is called pyrolysis oil. So from there, they are burning it in old machines. It gives a lot of this kind of haze, and that also has HCl. So HCl chemistry is really what is doing earlier for a whole decade. This was creating problem for ozone through this reaction, chlorine and bromine, this reaction, and it was breaking. So ozone was destructed. So net level of ozone was less when EPCA put ban on that. The plastic burning, this wrapper or all these things, illegal factory was closed. The chlorine and HCl in the air became less, and that was result of higher ozone. So ozone is seen higher, but practically it is background level reach, and that you can confirm because in rural areas already NO2 is higher than cities. Ozone is also higher in rural areas. Same way now, the plastic burning is not there, transports are not there, so nitric oxide is not there, and chlorine is not there now. These two cycles are governed. Ozone chemistry governed by these two things. So NO is not there because vehicles were stopped during pandemic, and chlorine already plastic burning was stopped by EPCA. So this chlorine is also not there. Because of that, in Delhi area in 2019, it was seen at some site, but after COVID, because now both chemistry working, ozone became very high. So in my opinion, we have to understand this and need not to be panic, but definitely we have to have advanced studies to confirm these things. What I am saying with the so it requires basically now to add another parameter we have to look for that table of criteria pollutant, that is HCl in ambient air, and that will really give through light on the ozone levels, and that is the need of the hour. And I have also, emphasized to revise the standards, national ambient air quality standards, because mm, today what we have, particulate standard, always, most of the time, particulate matter is violating the limit. If it's a violating limit, still people are not dying at that rate, it means there is something wrong with the parameter. It's a kind of a person, healthy person having high bp 100, means 100 and 150 like that, but he has no problem. So Indian region is having that kind of feature, that we we, we cannot take same chemistry what is defined for Europe and North America in India, because Indian region is having, like, you might have seen one example in COVID, that all projection of death, they collapse, because Indian region is having different, like atmosphere, same way food habits are different, immunity of person, the working conditions are different, that labor class didn't get any kind of that pandemic effect. So from that, just we cannot copy ditto these kind of things, and we need to have our own studies in order to rule out any ambiguity in that. And these, for these reaction, three people got Nobel Prize in 1995. One of them, Paul Kurjan, who comes from our lab. I also work in the same department sometime, 25 years. So now I will tell you, these are the results, when the ozone was reported very high. This is our paper we published last year. This April, May, June, this was the high at some site. This was a DTU, Delhi University, Delhi Technological University site, where, Mondka, that area, a lot of plastic burning is there. In that area, we got what is there after that shutdown. If things are changed, and this was especially credit goes to EPCA to shut down all these plastic burning, even the open fire, all these things EPCA took care. And after that, the environment became better. I will tell you another example if time permits. But why I related this mm, chlorine chemistry with ozone, high level ozone, in long back, 95, we did one experiment when I was in National Physical Laboratory. That time there was a huge fire in plastic scrap market. Plastic, old material that was burnt. Huge fire that covered, a huge area in the sky. The black sky was there. So we collected dust deposition that time and analyzed for their water soluble content. That time you see here, we had highest chloride, and this is the region. Now our results, very old results, and results presented by somebody in US in collaboration with IIT Delhi. That result of chloride and our background of EPCA field visits and factory knowledge, everything put together, let's take this interpretation I gave, that this is definitely due to plastic burning. The destruction of ozone is reduced. Now the building up concentration levels of ozone are seen, but these are not the higher ozone, but it is real ozone, basically background ozone right now. Should be in natural condition, but that time probably we don't have result. If you go back before 80s, we don't have result. Before 80s, if you compare ozone level, you will probably get similar what we have today in the pandemic. Then coming to another major pollutant, which I always talk about Indian region specialty. A lot of work I have done focusing on this aspect. Dust, atmospheric dust. It's mostly this soil dust, road dust, construction dust. It is three types basically, and in urban areas basically it's a mixed dust having all three components. Soil dust is mostly calcium carbonate, silica. It is coming from local soil suspension, LUCC, land cover change, long range transport, and road dust is research banded soil, which is basically rich in heavy metals, carbon, and organics. And construction dust is cement rich, mostly silica, alumina, iron oxides. Three types of dust, they have different consequences on health and climate environment. If it is pure natural dust, it won't have much bad consequences. But if it is road dust and construction dust, definitely our health is going to be affected. And if you look at this is the, everywhere you might have seen in India, especially in North India, this kind of dusty go downs, roads, kacha roads, all this happen. This goes to atmosphere, and dust is reactive, is highly reactive. So it reacts with the acidic gases like sulfur dioxide. It forms calcium sulfate. So this is one of the regions that sulfur dioxide levels in India are low compared to the other places, because sulfur dioxide readily is scavenged by calcium carbonate particles forming calcium sulfate. I will tell you more detail about that. And if you look at this right side, that is the region high particulate matter we have seen in northern India, especially compared to southern India. You see, this is the map showing calcium content in aerosol, suspended particulate matter, over Delhi, and same season over Indian Ocean. I was part of Indian Ocean experiment. We have, we had this ship Sagar Kanya 4 years, 95 onward, 99. 4 times we went during our winter season to see the effect of air pollution and to over this Indian Ocean, what kind of chemistry and transport, because uh, mm, when we did a lot of experiment 4 years, we got basically more knowledge about the sources. The budget is also basically uncertainty of budget is also reduced. Indian Ocean experiment basically was the triggering exercise for global community for going more advanced research on atmospheric chemistry. And atmospheric brown cloud program was part of, means basically it was byproduct of this Indian Ocean experiment. Later on, there was several experiments like ISRO did LC1, LC2, ICAR, Indian, and then further now many things are going on. But Indian Geosphere Biosphere program contributed a lot in this atmospheric chemistry, and now a lot of advanced knowledge we have about carbon, nitrogen, sulfur, acid rain, global change, climate change. India is very proactive. India has contributed towards commitments, whatever we have made for climate change. I think in developing countries, India was the first to submit its climate change report in 2012, I think. So these all these things, basically, but I am saying why I am saying that Indian Ocean experiment when we did, we found that continental side they are having a lot of dust, but deep Indian Ocean region the dust is not there, and that's why uh, the feature atmospheric chemistry is different. And I tell you, uh, before That I just want to tell you that atmospheric dust is also rich in carbon. We did a lot of work on the dust and carbon, is organic carbon and elemental carbon in that, and that shows that this carbon is not accounted for. Normally, in estimates, we are counting part PM10, PM21, but the dust carbon, as I told, it's a 100 micrometer, 50 micrometer coarser particles. So this is not accounted for. We need to account for that. Now, this slide basically shows particulate matter, why it is high, what are the regions, and this, left side, I have plotted, air pollutants, national ambient air quality standard also there. You can see here this red dotted line basically. These are ambient air quality standard line. So look at this. This standard line is always above. Here also well above. Here also well above. Here also well very high. So only in case of particulate matter, the line is always below. The particulate matter is basically, as I told, the Indo-Gangetic plain, very high density of population. We are using lot of things, so our energy needs all these. They need basically they emit a lot of pollution, and in addition to that, we have a lot of natural pollutants also, natural dust also in this region. That you see right side, this is same map from Africa to in third digit India to over digit China. So lot of dust we have due to natural regions. From that angle, it is quite obvious that particulate matter is always violating the limit of the national ambient air quality. I have compared this with Diwali. The right side of this graph always this Diwali time. Right side half is Diwali time. So this you see, in Diwali time NO2 becomes high, but most of the things are not changing much because about every day this kind of diurnal variation goes and this. So what I mean that other pollutants are not problem, but particulate matter is a problem for India, especially in Delhi. And if you look at the top 10 locations for respiratory particles, this is 2008 data, but still it is valid. The trends are similar. If you look at this top 10 locations, they fall in North India only. North India, because it's full of dust. You see in this map. What if we look at NO2 top 10? They are near Kolkata. I don't have graph, but I wanted. I have uh, in my other thing. But NO2 is always high near Kolkata. No, top 10 in near Kolkata. So because you have very bad traffic, and because of that, a lot of NOx is emitted. Most of the NOx sources are from transport. Mostly urban areas, they are having this. Now, this right side down, this is the graph showing the South India versus North India particulate matter. Suspended particulate matter, if you look at this is going, this scale is going up to 500 something. Then right side, this scale is going only 100 something. So this is the difference in North India and South India particulate matter. Here, different side, while making this scanning, these figures are diffused, but I tell you, these are mostly Delhi, Ghaziabad, and then it going Varanasi, that type of, these are the Chennai, Chittoor, those cities. So from this, you can see there is a lot of difference, and that's why in the revision exercise, I have emphasized that for particulate matter, we should have different standard for North India and South India. Because the problem is, if you are implementing only one standard and the particulate matter level become high, the North Indian industry get problem and they are basically asked to shut down. whereas the problem is not there. The problem is natural, which is not sometime in the hands of industry, but industry should be played. So from that angle, I think it is wise to have particulate matter standard based on this geographical and atmospheric scenario difference. Now, role of dust. India, what is the role of dust? I have already some points told you. The dust stage basically having and creating several types of effects. One is that it is giving a health problem. As you know, when we are basically breathing, we are breathing around 36 meter cube air per day, and that air is having almost these I calculated total gases and solid. It comes to something like this particle inhaled during 24 hour. We are inhaling around 18,000 microgram particle, and NO2 1800 microgram, black carbon 360 microgram. And then when it is differentiated in terms of adult and male and female child, and that you see we are having this microgram inhaled per day SO2 NO2 in this category like that. So it's always the ladies and children, although they are inhaling less, but they are very sensitive that for air pollution. And air pollution is participating our climate, uh, climate change, climate cooling, and absorption of radiation. It affects, radiative forcing. So if it is carbon soot, it absorbs higher radiation, so it is positive radiative forcing. It contributes. If it is ammonium sulfate, no, pure dust. It is scattering nature, and it negative radiative forcing. It contributes. So mostly in warming in urban areas, warming is there due to carbon content, and also I tell you, ozone and high. One of the reason is dimming, because when it is high carbon in the atmosphere, then solar radiation it should come. It is not coming that one. So it is the total solar insolation becomes less and photolysis less. Because of that also ozone become uh, high in this scenario before pandemic. During pandemic, the haze of carbon particle is removed, solar insolation is proper. So from that angle, ozone is high. So this is another reason contributing to high ozone. Then we have material corrosion. Material corrosion, you might have seen where dusty areas, your things get affected. Even the any utensil or ornament in house, dust is always there, moisture is always there. It react and gives corrosion, and even that. Um, Beside that, photo frame also dust particles are transported, that is through diffusion. So it's not that coarser particle, dust particle. You know, when you inhale sometime in dusty area, you sneeze it, because some people are very allergic, they get allergy. So dust particles are also very small particles, giving a lot of health problem and climate problem. But the good thing, another upper, dust is deposited on the stomata plant, and it affect chlorophyll formation, and also it changes biochemical properties of plant. Sometimes, plants mostly near industrial industries, in the industrial areas, they are under stress, and that stress is sometimes too much for the survival. But good thing is that whenever rain is there, it is washed out, and then plant breathe properly. So this is bad effect. But the good thing about dust is that dust stops, prevent, control acid rain. Acid rain, which are very common in North America and Europe. In India, it is not there because of alkaline nature of dust. Because if you look at this table, we have pH of rainwater at different sites. All the site you see pH is very high. I just remind you that any natural water will have pH some acidity due to carbonic acid, which is formed by the atmospheric CO2. Any natural water, pure water is having pH 7, but any natural water will have dissolved CO2, and that means carbonic acid. Carbonic acid pH at this present concentration is assumed at 5.65. That is taken as the reference pH. So pH below 5.65 is called acid rain, not the 7. So we have in India mostly pH above 5.65. You see here, even 8.3 there in Jodhpur because desert soils are very highly alkaline. So from that angle, we are born nature basically. Nature is protecting us from the acid rain. But look at this Indian Ocean and acidified regions, Europe and America, pH is below 5.6. As I told you, when I used to go to Indian Ocean, the time I let me give you one tell you a story. When first time in 95 December I went, the Indian Ocean experiment chief scientist was Professor A.P. Mitra, with whom I worked, and so you are Director General of CSIR. So we went in 1990. He was in NPL, but the team went basically. I was research associate that time. So I collected rain water, and before that also I used to study rain chemistry in Delhi, Agra, these places we did. Even I did the Darjeeling there. So we used to have pH 9 and always high 7, 6.4 like that. But over Indian Ocean, first time I saw pH, it was always below 5.6. When you have this kind of contradiction anomalies, you don't believe first time because yeah, first time only you are encountering such problem. So I didn't believe. Many times I measured with this let me tell you, ship is having laboratories. So pH meters are available. We also carry our pH meter. So there again and again I measured, I whether it's a fault of bottle, storage bottle, collection bottle, or pH meter or buffers are okay. Several exercises I did, but I was not satisfied. When I came back at NPL again, I checked. It was that low for on something 4.55 like that. So somehow that we did chemical analysis and found sulfate high compared to calcium, the ratio if we say compared to Delhi. The next year we got a similar type of pH, and I was satisfied that our measurement were okay. Only thing that sample nature was different, and that gave my full basically opportunity to explain the Indian region. And I explained, I worked on this phenomenon to explain for around more than 10 years. And then our counterpart in Europe also got convinced, yes, this is really happening due to this dusty nature. And that I will show you how we did different experiment to explain it. But this was really, and that gives message to you people that any if you are measuring correct, your measurements are okay, taking our precaution while sampling and analysis. Don't worry, if you don't have right interpretation that time, but don't cook your data and don't compromise for the sake of happiness. You be with that, repeat it, and definitely you will get interpretation one day. So same thing happened with our this acid rain thing, and for that I got award also, starting scientist award. Later on, we continued and gave different kind of interpretation also in rain chemistry. So this is something I have made this what happens to sulfur chemistry in India. And this is basically sulfur dioxide is getting adsorbed uh, onto dust particle, making calcium sulfate. And because we don't have rainy days in Europe, if you see, uh, most of the time it rains and the particles are scavenged, so the atmosphere is rich in gases rather than particles. And moreover, they don't have this kind of dust, so the atmosphere is not having buffering capacity. In the absence of buffering capacity of this SO2 oxide formation, it is having, uh, the pH as shown here, as you see here. The sulfate in rainwater is having, two types. One is coming from sea. Sea mean DMS H2S, that sulfate, which is not much contributing in acidity. It's a neutral because organic it's a MSA, methane sulfonic acid. So then it is only the sulfuric acid coming from sulfur dioxide oxidation that creates acidity. Free acidity is due to that. And when it rains, it is given dust, and also already dusty particles are there. That's what is reacting, making calcium sulfate, and that is given by the rain. It comes, always we read pH more than 5.6 in India, except few cases when rain is continuous. I will tell you that also. But in general, this is the chemistry, and I tell you this work I did, and my wife is also a scientist, and we together explain this thing, published a couple of papers on this aspect. Then if you look at that, whether I'm right or wrong, if you see the global distribution of pH, this is also, very high pH in this belt where the dust is there, as I showed you, and this is very low pH when temperate region. Basically they have low pH because temperate region there is no dust, there is no calcium carbonate much in the atmosphere. The atmospheric nature is very different what we have in Indian region, and this tropical belt cold. So this is a kind of a natural boon for India. And I tell you what is the benefit of this is that Europe and Northern America, they put huge money to they invest huge money for liming of lakes to protect from acidification. But India, that way we are protected by the dust. So huge money, we need not to spend so much money for that. All this natural, basically, nature is mm, helpful in economy that way. So another proof is what I am saying is the comparison of sulfate, nitrate, and pH in India and US. If you look at this variation of sulfate and pH, normally your chemist, I don't know whether chemist, but in general, if sulfate is high, pH will be low because sulfate is considered as sulfuric acid. If sulfuric acid is there, then H ion will be high, so pH will be low. So if acidity and means sulfate and pH have, inverse relationship. It same way in Europe, Sweden, same trend is there. It's a negative. But in India, trend is different. Even at high pH level, sulfate is high, or even high sulfate level, pH is high. That is contradictory because here in India the dust is there. So it shows that, when we are doing research, when we are explaining, there are two types of research. One is characterization of material, another one is working on establishment, interpretation of phenomena. Characterization of material is at, the timing, just very short-lived things, but phenomenon you have to work to the, then you have to conduct experiment, repeat experiment, different type of experiment, different types of analysis. Then you can have a calculation also, back calculation, theoretical comparison. And all these things put together, then only you come to conclusion that is the phenomenon when you explain. So this is one of that comparison. I just want to prove that this is really Indian atmosphere, and nature is different, behavior is different. So we have to be aware of that. Accordingly, all decisions should be there. I have highlighted the importance of dust for even ammonia, dust for ozone, dust for climate change. So the one way it is good that whatever coal combustion is there, sulfur dioxide is emitted. Sulfur dioxide get oxidized, and dust is there to trap it. So whatever if you are emitting from SO2 point of view, Indian atmosphere is fully capable to deal with from this won't give any acidification, but it is a problem of carbon and CO2. So if we control, carbon emission from coal, probably there is no problem in India to use coal even because sulfur dioxide is not the problem like unlike in Europe and US. So this is something which I just wanted to convey, that this one comparison gives lot of advantage for Indian atmospheric chemists and also the policy maker to make use of this natural principle. Then we did another experiment that was related to whether how dust, how dust is removed. How dust is removed. I just did this experiment in Hyderabad, and we found that if dust is effectively removed by rain, what we did, we collected aerosol sample and rain, do before rain, during rain, after rain, like that. And although it is very risky and also costly, sometime the pump the pump of that sampler is also burnt, during rain when you are collecting some kind of droplet, it goes. So it's a well, mean when sampling is a little, tedious for this kind of work, but we did, and we found that calcium 75%, 74% calcium is removed during rain. This is Hyderabad, but when it comes to Delhi, it is even more. You might have seen the news that rain, uh, yeah, this one, rain, Delhi air quality improved due to rainfall. That basically, the, this is very recent in 2018, but our results were quite old and we scientifically established. So what am presenting, scientifically from chemistry research to the societal benefit sort of thing, that approach I had, and from that angle, what we did, that uh, we demonstrated scientifically that dust is effectively removed by rain. And then that consequences of dust were not there over Indian Ocean. As I told, this is the map of India, and this is near Trivandrum. What if you see here, calcium is near Goa, and pH is also very near. So when it comes to sulfate and pH, this is matching near Male. What calcium is much means removed from the air near coast, because it's a coarser particle, they cannot travel transport it far. So air becomes gas rich and sea salt and gas, SO2 and fine particle accumulation, rain particle, mostly sulfate particle. So these are incorporated in rainwater, gives acid rain. But that that's why the graph which I was showing Delhi and Indian Ocean, it was having high calcium at Delhi but low calcium. So this proves that Indian atmosphere is different. Indian Ocean atmosphere is very similar to Europe and Northern America during winter period. Let me emphasize winter period. Summer period, monsoon period is different than the winter period. Trade winds are different when it comes to winter period. Winds are moving from this side to this side over Indian Ocean, from China side to also Indian Ocean. So it carries pollutant from this continent and go to this side. But when monsoon comes, air moves from here to north side, this side. So already ocean is clean. The cleaner monsoon air are monsoonal air parcels are cleaner compared to winter coming from continental side. So another very interesting thing I did, that is I think good to share with you, that in rainwater, we analyze two component: sea salt, sulfate, and non-sea salt. Because in Europe mostly there are only two sources for sulfate. One is coming from sea and coming from industry. So when calculate, we calculate based on chloride ratio, and chloride ratio basically that differentiate sodium ratio, like chloride by sodium, sulfate by sodium, potassium by sodium, we calculate, and based on that we differentiate sea salt, sulfate. But that was true. But in India, I never saw that correlation, non-sea salt sulfate correlation with pH. So what I did, then I thought, in India things are different. This equation and it came into my mind, and I calculated further, basically differentiated further non-sea salt sulfate into crystal associated and anthropogenic fluid, and this is responsible basically for free acidity. But this is calcium sulfate. It is basically produced due to buffering action. So I calculated based on that. I plotted after this. If you see this, the green thing, green part is neutral. It is coming from sea salt, but the ratio of brown to yellow, if you look at it, if it is low, pH like Delhi and Indian Ocean, that becomes pH low. If brown is high, brown to yellow ratio is high, pH becomes higher, unlike continental side. This was very interesting. We published this thing, and it's quite important for Indian region. Now, acid rain, as I told, do occur, but very less. Only when rain is continued for a longer time, it removes particles. There's no calcium, then buffering is not there. Rain may be acidic, slightly acidic. We don't have very high acidity like Europe, but slight acidity means 5.2, 5.35, like that. If vegetation cover areas are there, like northeast mostly, it is also the pH is sometime below 5.6. If the areas where soil is acidic, like Kerala, coast, even the Odisha area, Nandanganan, there laterite soil, that also gives acidic rain that time. And then near thermal power plant, when SO2 is high, particulate matter is even the rain and other thing, that gives free acidity and acid rain occurs. But acid rain frequency is very less. If you look at this, Bhubaneswar, Hyderabad, frequency is 10, 15, 20%, but over Jawarahat and acid rain is more. Now, major feature of air pollution in Delhi, because Delhi is capital, is always in news. And I was part of EPC also, so it's a good to mention. In Delhi, we have particulate pollution, and that particulate matter has basically influence from land use, land cover, change lot of house building, making, construction, and that all dust is settled through dry deposition, scavenging through rain, mechanical device, and wet surface, all this general method. And what is the required thing is that when pollution is too high and natural and anthropogenic components are mixed in that, there is a need to differentiate how much is natural, how much is. And this paper already I published in 2015. This is required, that PM 2.5, just like that. If we say we cannot justify, we have to have chemistry of that. We can say that PM 2.5 for heavy metal, PM 2.5 for POPs, and PM 2.5 carbon, like that is something. It is good to have this kind of classification, and then you can connected with the health risk. Otherwise, it's very difficult to decide and talk about policy level anything. Then other related issues are related quality control data, interagency interaction. We have, uh, very less coordination between two agencies. Now, in this paper only, I have highlighted there should be some interstate body. Now, the commission here, commission is established. That kind of body already I suggested in that 2015 to control it. So this is good to have better coordination between two four states of NCR, and also the leadership issue there in tackling air pollution. This is something that now what we can do, what we should do. There, if you look at this, uh, we have different type of problem of air pollution in India. So tackling it needs are different. What we are doing right side one, we should not focus meant, because if you look at in US and India, or developed country versus developing country, that we have lot of traffic congestion. They have industry, we have industry, fossil fuel, we have emission technology, we have. So solution doesn't lie here, solution of pollution lies here. Basically, it's what we have different, so we have to focus upon that. And accordingly, this is, we have very less rain, so a lot of dust is there, accumulation of pollution is there. So we have to think to make rain, how to do this. I have suggested to make lakes. And mostly we have dry weather conditions. If they don't have dry weather conditions, so that is, we have to consider. We have a lot of dust, we have unpaved roads, open burning. We have to control all emissions coming out from open defecation, brick kilns, number of, we have a lot of vehicle congestion is more, and construction not this thing. So this is somewhere policymaker, they have to apply this criteria and particle selection. And that's already I told, rain is effective removal of dust pollution, because dust is nothing. It's coming out from open source, area source. So the scavenging should not be like, what we are doing, sprinkling water, and that is, they will not work. Tower thing will not work. Although I do not discourage, but for a technology's sake, use, and also kind of trial sake, no problem. But effective removal can be done by rain somewhere. Uh, Without that, it is not possible. But as you see the results, we cannot deny the result. We have to, if these are correct, then we have to follow that kind of solution. And then, COVID-19 cleaning air is follow up of two successes story. COVID-19, we have seen very low pollution, very effective, air quality good. But that before that, also two things happened. One, in China, a lot of pollution control was done by Chinese government, and so the pollution level came down. But further, it is down in to COVID period. Same way in India, EPC did lot of efforts in 2018. There was program called Graded Response Action Plan (GRAP). Whenever GRAP was implemented, the particulate matter became down. You see the red arrows, and these two figures, they convey. They are in 2019, before lockdown. That time also visibility of Delhi increased due to EPC efforts. From IIT to Greater Noida, this you can see the photograph. From IIT to Badarpur thermal power plant was seen. This was sent by one of my friend in IIT. So this shows that efforts were done, and this COVID-19 air cleaning was another example of global rejuvenation of atmosphere. We had greater visibility, very high quality, lot of birds, and even river water. Would. Now, what I suggested to control air pollution in Delhi, we have to have two minimum two big lakes like Usman Sagar, Himat Sagar, what we have in Hyderabad. From these lakes, in the during day, water is evaporated due to transpiration, and a lot of, occasionally you will have rain. Rain will scavenge dust, and that happens quite frequently. a big lake, not a small. Those who have seen Usman Sagar, it's a 5-7 kilometer, So that kind of lakes are required, and probably these are also work is also started. I saw on news that kind of thing. What is the advantage of this? This is holistic approach. In fact, I have started one program, holistic environment. In that, this kind of solution we have provision to suggest. So in this, if you look at the more water evaporation from lake will trigger occasional rains. Rains will scavenge atmospheric dust. It will wet unpaved roads, open soil, controlling resuspension of dust. Lake will control desertification, which is the problem of this area. It will support groundwater recharging, and also it will have a biodiversity enhancement. So many, and these are the how to tackle it. I suggested these are the some options you can do. R&D related some effort you can do. You can emphasize for quality control, monitoring data. This is the problem nowadays, the quality control. Then uniform sampling protocol. Some sites are 10 meter above, some 5 meter from the road, but other site is having different connection with road and altitude. Some sites that kind of, so protocol should be same site from the road, and altitude of sampler should be same or all site, that should be taken into consideration. Then only one nodal agency should be there for top management, that two ministries are doing. That should not be the case. One air quality index, if you see, and the Ministry of Earth Science is having 5 steps, and Ministry of Environment and Forest, climate change is having 6 steps, CPCB. That should not be the case, because after all, air quality index is made for public, for generalized thing, for making it simple. When it comes becomes complicated for public, two types what to follow. This is a kind of ambiguity. Then we have policy related efforts. We should do that control of construction of dust that happen now. Green, the cloth they put, this is good thing to stop the uh, dispersion of pollutant and improve road conditions. This is very much required, because then express bypass road for the going on these things. PUC pollution under control check, certificate should not be given just like that. It should be very stringent. And then Bharat 6 standards, already it's done. Then switch over to CNG and provide improved stoves to replace traditional chulas, stop biomass and biofuel burning for winter heating, which is now also quite now strictly followed. Make compulsory primary education within 5 kilometers, which will stop running of buses from here to there. Even the parents are going and using lot of fuel. Then introduce work from home scheme, that is now done. I'm very happy. Most of these things are noted by the policymakers, because 2015 onward things change after that paper. Interstate task force, that also is almost done. Use of air purifier and water sprinkler, if it can be done. And at home, air purifier people are using. The more public awareness campaign, they should be done. And we did that for Diwali, and no to cracker, one of my the group. That kind of efforts we should do. And I'm happy to tell that I have one network that is called Deposition Research Through Student Network. It is in several site, and this is run by students, because my projects when they were stopped, I started this with the contingency of student. So all credit goes to student, whatever work I have done at JNU. Thanks to them, we are having a lot of sites, and this is these are the parameters: sulfate, nitrate, NO2, ammonia are done. With this, I thank you very much. And if you have any question, please ask. I think it's a 7.
Yes. Thank you, Professor Kulshrestha. Actually, we got such an illuminating things. We did not know many of the things earlier, so naturally we could strengthen our knowledge base. So many thanks for such a knowledgeable professor like you. We request more interaction with our organization, our ashrama, and also with Jadavpur University. In future, we will contact. Thank you.
Okay. Thank you very much. Thank you.
We are eagerly waiting our next speaker,
Yeah,
Dr.
yeah. I will just log out.
Yes, sir.
Mm,
Yes, sir. No problem.
Thank you very much. All.
Yes. Dr. Kanath Bag, I hope sir has joined. Dr. Kanath. Dr. Kanath, please unmute. Yes. Yes. So already the speaker has been introduced 2 times earlier. So I mean in our earlier lecture, his earlier lectures. So I request Dr. Bag to start his proceedings. Sir, please.
Okay, thank you. Thank you, sir. So, the long day, a lot of lectures. I, I maybe the last one. Anyhow, my topic today is accidents in industry and sickness absenteeism. So let's first check out whether I'm clearly audible to you or not. Yes, Arpita, am I audible? Arpita Chakraborty?
You are quite audible, Dr. Das, Dr. Bag.
Okay. Thank you. Then let's proceed. I'm sharing the screen with my first presentation. That is the accidents in industry. Accidents in industry. The learning objective of today's presentation is that certain definitions about accidents. There is measurement of the problem, the multiple causation of accidents, and definitely the prevention of accident. Accident is a major problem in industry. Let's see what exactly meant by accidents. Some says is an unexpected, unplanned occurrence which may involve injury. Some other people say that it is unpremeditated event resulting in a recognizable damage. In other words, occurrence of in a sequence of events which usually produces unintended injury, death, or property damage. Not a way to explain something, but here you can note one thing, that the word, the prelude of unexpected, unpremeditated, unintended, as though accidents is something which we cannot foresee, which we cannot predict, which we just can't do anything about it. The accident is accident, but nowadays accidents are no longer considered accidental. Accidents are no longer considered accidental. In medical terms, accident is considered as a disease. They are the part of the price we pay for technological progress, and accidents have their own natural history and follow the same epidemiological pattern as any other disease. The crux of this discussion is that you should always remember accidents are no longer considered accidental. And accident is like any other disease. Like the disease is having a natural history, like before it affects a human, it's having a course. When it affects the human, it goes in a particular course, and after that the individual is either died or disabled or cured. Accidents have all these features. Like we discussed about any other disease, there are certain, and for any disease there is a disease agent. The host is the human being and the environment. This interaction between this agent, host, and environment causes the disease. In the case of accidents also, there is certain agents. There are the host is the individual, and there is a lots and lots of environmental factor that precipitate this condition. This is having all the characteristics of a disease. And nowadays, accidents are considered as a major non-communicable disease, and accidents are no longer considered accidental. With this understanding, we try to measure the problem. Whenever there is an accident, there is mortality, and that is the death. It is not that all the accident causes death, but one outcome of this accident is definitely death. When we measure the problem of accident, we first measure the problem with the mortality. How many lives? But in this matter, I just want to tell you that it is not the sheer number of deaths. If you try to enumerate, only if you try to count the number, it may sound very little, but it is the proportional mortality in different terms which actually measures the problem, which actually sees how grave is the like number of deaths due to accidents per 1,000 total deaths. It is not a single number, but if we compare it with the total deaths, then it will come that what exactly the magnitude of the problem. If we for the industrial accidents leading to death, if we consider the number of days, it may be very little, but if we consider that number of days spent in the workplace and the number of days, if we compare it with the number of deaths due to other causes in the industry and due to accident, if we consider the number of deaths in terms of the particular shift the individual is employed, then we'll be able to judge the problem. For any measurement of any health-related problem, I just want to tell you, it is not only for the accidents, but for any death or any problem. try to find out the denominator. The denominator is the most important thing. It is not the numerator, but the denominator which is the most important. Whenever in any epidemiological parameter, it is the denominator that is the most important. The measurement of the problem of accidents start with the mortality, and not only that, okay, before we go to the next parameter, morbidity, I just want to emphasize on that this death can be instantaneous, immediate death within a couple of days. But in most of the time, accidental death is considered the death if it happens within 1 month of that death. So that death due to accident may happen instantaneously, immediately within a couple of hours or days, or even it can happen after a couple of weeks. But if it happens within 1 month, it should be considered that it is the consequence of that. Next measurement is the morbidity. Morbidity, I am not going into details, but the morbidity is actually considered as per the abbreviated injury scale. How much that individual has been injured, what is the extent of that injury, and how long this individual is suffering. All these things comes together to form the abbreviated injury scale. The next parameter to find out the problem is definitely the disability. It is very difficult to find out the disability arising out of the industrial accident, because it is not only the physical disability that matters. It is the psychological disability, economical problem, all these things coming into play. And we have tried to find out that disability as per the international classification of functioning disability and health. So with these measurements, we try to assess how problematic the accidents are in the industry. Anyhow, after measuring the problem, if we go into the causation of the accidents, we find that basically there are two factors. One factor is the human factor, and another factor is the environmental factor. Anyhow, in the human factor, there are physical factor, physiological factor, and psychological factor which comes into play. The physical factor, in the physical factor, the most important is the physical capability. The individual who is performing a particular job may not be physically capable of doing, or may not be fit enough to do so. And that exposes the individual to risk of falling into accident. There are some physiological conditions which makes an individual prone to it. Like there are the sex of the it has been found that ladies are less vulnerable to industrial accidents than men. It may be because of the nature that they are very cautious about. But it is well established that ladies are less vulnerable to industrial accidents. Regarding the age, the vulnerability reduces with age, and you can say that there is a U-shaped pattern. In the beginning of the career in industry, there is high chance of an individual is meeting with them. The most the highest level chance maybe within a couple of months of joining them, because the individual who not established a safe practice, it is not ingrained into his body and mind, and he has not developed a habit of following the safety measures. And on top of that, he is not able to find out or recognize the warning symptom of it. And that is why in the initial phase of his experience, initial months of employment, he is more vulnerable to. As the age advances and the individual becomes more and more experienced, more habituated with this work, more comfortable with following the safety measures, and more vigilant about recognizing the danger signals, he is becoming less vulnerable to accident. Again, at the fag end of his career before the retirement, the person, due to the aging process, it becomes slow, slack, and less attentive, and that makes him vulnerable. So one very good practice is that whenever an individual is introduced into the industry, he may be given less hazardous job, less accident prone jobs, and with the advancement of his career, with the advancement of the experience he gained, he should be shifted towards more responsible, more hazardous, and more jobs that deals with the dangerous operations. And at the end of the career, before the retirement, he should be given we should be given more safe jobs. And that is a very good practice to reduce the accident. The timing of the day and the week of accident is very, very important. It has been found. It has been found that whenever there is increase in the duration of work, increase in the shift of the work, then there is the increase in the incidence of accidents. Not only that, it has also been found that accidents usually happens at the beginning of the shift, and in the middle of the shift, the chance of accident is less. And again, there is some increase in the incidence in the latter part of the shift. It may be that in the beginning of the day, beginning of the day maybe beginning of the day, or maybe the individual may be in it. But as the days advances, it becomes very tight, and but at the end, again, the fatigue sets in and the chance of accident. There are other experiments or other findings which suggest that at the beginning of the work, the incidence of accident is less, because at the beginning of the work, the individual is much more attentive. So it's a good practice that that like we used to do in our school days, that we used to go for the prayer. But that sort of things can take place before the beginning of the shift. We can take a oath, or we can make a prayer, or we can promise that we will be attentive and to start before beginning of start of the, and that will be able to concentrate more on the work. And in the left part of the work, when the fatigue sets in, then we can remind them, that may be a reminding of the that we are coming to the end of the shift, and we have to be careful. As I have already told you that experience is very important, and it has been found that in the first 6 months, the total number of 50% of the accidents takes place in the first 6 months of their life, and another 23% in the next 6 months, and only 3% in the subsequent years. So first year is very important, and the first 6 months is most important, and because the individual is not experienced, and as I have already told you that it is not habituated, their safety mechanism inside the body has not started functioning. So the young people who have just joined the industry, they should be. As I've already told you that long working hours had its own toll, and whether the daily working hours is increased, that will definitely lead to increased accidents. Overtime is a common practice in industry, and, at times the workers they ask for overtime for more earning. But as a middle level manager or a policy maker, you should always be vigilant that where there is a hazardous process.
Sir,
Pardon?
sir, actually, sir, your screen is not visible.
So I have asked that whether the screen is visible or not. Nobody has told me. Okay, thank you. Uh, why I just- whether the screen is visible now?
Yes, sir.
Now it is visible. Now
Okay.
it is visible. Okay.
Okay.
Carry on, sir.
Okay, 1 minute. 1 minute.
In which slide you were now?
Yes. Let me change the slide.
Yes.
So am I audible?
Yes, sir.
So whether the screen has been shown to you?
No, sir. Now it is visible, sir.
Now it is visible.
Yes, sir.
So can you see that multiple causation of accidents?
Yes, sir. Yes, sir.
Okay, then. Sorry for this interruption. So what I was talking is that the multiple causation of accidents, the most important is the human factors. As I've already told you, there are some physical factors where the physical capability is the most important thing. There are certain physiological factors like that of the sex. Females are less vulnerable. The age, as I have told you, the young age is more vulnerable, but at the middle age, the incidence is less. And in the latter part, when the individual is at the end of his career, there is increased incidence. As I have told you, the time and experience, that regarding the time, as I have told you, that in the beginning of the shift, there are certain places where there is increased accident. But most of the time, at the beginning of the shift, the incidence of accidents are less. Because at the beginning of the shift, the individuals, mostly the individuals are tight and they are active. And as the shift advances, at the end of that shift, the vehicles become fatigued, tired, and the incidence of accident increases. Experience plays a major role in the incidence of accidents. That more and more the individual becomes experienced, habituated with the work, and conversant with the safety mechanisms, and can recognize the signals of danger, the incidence of accident decreases. The first 6 years is most vulnerable. Sorry, the first 6 months is most vulnerable, followed by the next 6 months. But after that, the incidence really decreases. So, whenever an individual has been introduced in the work for the first time, it is better that that individual should be gradually introduced in the most hazardous operations. If there is an increase in the working hour, definitely due to the settlement of fatigue, the incidence of the accidents increases. But at times the workers are also interested about the overtime because of the financial reason. But we should always keep it in mind that there should not be any overtime where there is in more hazardous operations and the operations where there is there is chance of accidents. The psychological factor plays a major role, and the psychological factors appears to be more important factor than the physiological factors. The psychological factors which is responsible for causation of accidents are that at times carelessness and at times overconfidence and inattentiveness and slow celebrations and ignorance. All these things come into play. But apart from this human factors, there are environmental factors. When there is an increase in the temperature in the workplace, it has been found that the incidence of the accident increases. If the workplace is ill illuminated, the humidity is more, the noise is more, and the machine is unsafe, then there is definitely chance of accident. But I am telling you, it is not the environmental factor, but it is the human factor which is most important. It has been found that the cause of accident, in the cause of accident, the most important factor is the human factor. About 85% of the accidents happens due to human. Only 10 to 15% of accidents is due to environmental factor. And in the multiple causation of accident, it has been found that the human factor and environmental factors play together. It is intermingled. It is working simultaneously, and both these factors are actually controlled by the human factor. Because if you find that the temperature in the workplace is low, you should take the high. You should take the human factor should take the measure, change that. If it is ill-illuminated, the measures should be taken to increase the illumination. So the human factor is actually playing a major role. And with this, you can very well understand that it is the accidents are not accidental at all. You can predict that this is the time when the accident can happen. This is the place where the accidents can happen. This age is vulnerable for accident. This work experience is vulnerable for accident. And these are the psychological factors which can make an individual prone to this. And these human factors and environmental factors, they play together to increase the vulnerability or the risks. And whenever there is increased vulnerability and risk situation, there is certain precipitating factor comes into play. These precipitating factors are alcohol and drugs abuse, there is family disharmony, and social pressure. These factors, though this alcoholism and drug abuse are well seen, but the social pressure or the family disharmony is not visible at all. An individual who is coming from have a problem in the family and have some social pressure or maybe anything, maybe for earning more, he has to work overtime, and these things precipitate the already vulnerable or at risk individual, and the accident happens. So this is how the multiple causation of accidents play. And with this background, we are now going to find out that what are the measures that can be taken to prevent accidents. As I have already told you in our previous class, that the prevention are in 4 levels: the primordial prevention, the primary prevention, the secondary prevention, and tertiary prevention. The same is holds good here in prevention of accidents. And it is not that very elaborate, large things can be done, is to be done, but there are small things that can change the situation also. Let's see what are the couple of things that can be done very simply. First important is that pre-placement examination. As I have already told you, in the prevention of occupational disease, to prevent accidents in the occupational field, that the pre-placement examination is important. You have to find out the right person for the right job. If the person with is not having a specific capability has been put to a specific job, there is every chance that the individual will meet with the match. Pre-placement examination is very important. Not only that, there should be periodic examination of the individual, that whether he has developed any disability or defect or any thing which can make him prone to like that individual is working there, but due to any reason he has developed a musculoskeletal problem, and so the individual should not be put to a work which requires to place himself in an higher place, like that at height on the ladder, or in the corner of a building or installation. So it is not only the pre-placement examination, but a periodic examination is essential for every worker. Job training is another important thing. To start a job, the individual should be trained initially. And not only that, even after doing so, that individual should be retrained. And it has to be found that whether that individual has been doing as per the standard protocol or not. If he is not doing as per the standard protocol, he should be retrained. Otherwise, there is every chance that the individual will. We have to continue the safety education throughout the year. It is not that just a poster that safety first in the industry. It is continuous exchange of views and the problems the worker is facing and the difficulties they are facing, that has to be discussed. You may find that you have given the gloves, safety gloves, given the safety helmets to everybody, but they are not wearing it. So personal protective equipment, why that should be used, and what's the consequence if it is not used, that should be continuously told. And if there is any problem like that of the helmet, safety helmet which has been given to an individual may not be fitting to his head. So that has to be changed. Or the gloves is either short side or oversized. So these small things is to be addressed. And this safety education is a continuous process, and that has to be maintained. And the safe work environment. Regarding work environment, I have talked in details regarding different work environments. These all things holds good to prevent accident also. But here, one thing I am telling you, there are certain small things which really works wonder. Like that, if a machine is having a protruding part, whether that protruding part can be guarded or whether that protruding part can be eliminated, that can be taken care of. If an individual is working in that place, whether the person is wearing something which is not flowing. There should not be redundant excessive clothes which can get entangled with this. And these are the small things, but this really works wonder to prevent accidents in the workplace. Regular repair and maintenance of machine, it's very important, because if we go by the book and the schedule has been properly followed, and there is chance, there is less chance that the machine will go off, and there is accident. Maintenance of machine is so very important that if it is not properly maintained, lot of industrial accidents, major accidents happen in history because the machine has not been maintained properly. So there should be a chart. Actually, it can be placed over the machine, or it can be maintained kept in the office, and that regular checking whether the machine has been maintained or not is very, very important. Next thing is that a safety department. Yes, it is a statutory provision. We have to have a safety department in the industry, and there's in that safety department there should be a team. It is not that it is a job of a supervisor or it's the job of a safety officer and he is the responsible. It should work as a team, and the representative from all the corners should be there in that team, and there should be a safety meeting very regularly, and there should be exchange of views, and otherwise accidents in the industry can never be prevented. So careful reporting, maintenance of records and publicity is all that is needed. And with this careful reporting, maintenance of records and publicity, definitely the accidents can be reduced. At the end, I just want to tell that I'm taking it's the third session, and I'm repeatedly telling that it is the informed suspicion and the continuous monitoring which can save the day. You have to be very, very suspicious about things, about the environment, about the machines, about the time, and you have to be very, very careful towards your people. Unless and until you are suspicious to the surroundings and you are careful about the people, no amount of checklist or no amount of teaching can help you. So again, I am telling you, an informed suspicion is the key tool in the occupational health. With this, I come to the conclusion of this part of the lecture. I'm sorry that it has been interrupted a bit. Now I just want to switch over to the next part. That is the sickness absenteeism. I hope that I have been able to share the screen. Is that topic has changed from sickness to sickness absenteeism?
Yes, sir.
Okay. So this is today's last topic of discussion is the sickness absenteeism. Sickness absenteeism. Sickness absenteeism. Two different words. and it is because these two different words are clubbed together. Uh, the absenteeism due to sickness or the absenteeism for sickness. That is why these two words are clubbed together. Maybe the individual is absent because he is sick, or maybe the individual is absent because he absent because of some other reason, but he is telling that he is sick. But whatever it may be, whatever it may be, whether there is a true sickness or not, this sickness absenteeism is a major problem in industry because it affects the productivity of the industry. So in this discussion of sickness absenteeism, the learning objectives are: what is meant by sickness absenteeism? What is the incidence of sickness absenteeism? What are the causes? And definitely, what is the prevention we can go for? As I have told you, absenteeism due to sickness is sickness absent. This absenteeism may be due to real sickness, or the individual may present himself as. If we go by the definition, as I have already told you, there is no definition of disease. There is definition of health, and if an individual is deviated from health, the individual is disease. The disease may be recognized, recognizable disease, may be unrecognized disease, but the illness is something different than that of the disease. By the word illness, that means the subjective feeling of that individual that he is not well or she is not well. We say that, how are you? I'm not well. I'm ill. And that is the subjective feeling of it. And then what is sickness? Sickness is the role, the social role an individual play if that individual is ill. That means I am feeling that I am not well, I'm ill. And the role, social role I am playing due to this sickness, the illness is the sickness. Like that, I am ill, that is why I have not been able to attend the club. I have not been able to go to work. I have not been able to attain the marriage ceremony. That is the role, social role that it is. So, in industry, whenever an individual is become absent due to that the social role he plays as he is not well is called a sickness absenteeism. Anyhow, this is important because it impedes production with serious cost repercussions. In industry, it is a serious problem. It is important more so in sophisticated production technique. In sophisticated production technique, we need a more trained manpower, and the people are well trained, and less number of people work. There, the absence of a single individual hampers the whole process tremendously. So, sickness absenteeism impedes production with serious cost repercussions, and it is more so in sophisticated production technique. the useful index to assess health of the worker. It is a useful index to assess health of the worker because it is not only assess the physical, it also assesses the physical, mental, as well as social health of that individual. How it is so important? Let's incidents. The National Productivity Council indicates that there is marked increase in absenteeism. It was 8 to 13% in the year of early 1950s, and it has recently gone up to 15 to 20%. And it is as high as 8 to 10 days per head per day. It is not the usual leave an individual. It is average 8 to 10 days per head per year. It is out of what the individual is entitled to. That is the high incidence, and it is having a very high financial implication. And if we go by the causes of that absenteeism, you will be astonished to know that economic cause is the most important. It has been found that if an individual is entitled for paid sick leave, that there is a high incidence that the individual reported sick, because he thinks that if I don't avail my casual leave, it will be wasted. If I don't avail my annual leave, it will be wasted. At the same time, if I don't avail my sick leave, it will be wasted. So the individual reports himself as sick, and the individual reports back himself as fit. This is one thing. Whether this entitlement, cessation of this entitlement is will be helpful or not is questionable. But definitely, if that individual is entitled for a sick leave, it has been found that he is availing that leave even when he is not sick. Sick leave or sickness absenteeism is having a social perspective. There may be family obligations, like that of the marriage, like that of maintenance and repair of the house, like that of many festivals, and these family obligations has been met with taking leave, telling that that person is sick. There are other economic activities also. Suppose that individual is engaged with other economic activities. He has some piece of land in his countryside, and during the season of sowing or harvesting, he has to go there and he has to help his family members in this farming process. And for that, he needs some leave. And if he is not entitled for any other leave, or he is not been able to avail any other leave, he may take that advantage of taking sick leave. So other economic activities may also lead to the sickness absenteeism. And it has been found that 10% of the sick leaves are due to occupational accidents. So this is total, in the total sick leave, only 10% are due to occupational accidents. There may be other cause, medical cause, particularly the respiratory problem and gastrointestinal problem is a major cause. On top of this 10%, they are the major cause of taking sickness, absenteeism. But occupational accidents is only 10% of the total absenteeism. How much sickness absenteeism has been taken for other reasons, like that of the economic reason, social reason, and other economic activity? is yet to be found out. But yes, there is a considerable amount of sickness absenteeism is due to that reason. There may be non-occupational problems like that of the nutritional problem, alcoholism, and drug dependence. Alcoholism and drug dependency becoming a major problem nowadays. Not many individuals are getting affected, and truly speaking, the young generation incidence among the young generation is increasing. We have found that there is less incidence of smoking cigarettes, but there is very high incidence and increasing incidence of alcoholism among the young generations. Drug dependency, particularly the winds, is becoming a real nuisance. Lot of industries it is doing havoc, and uh, like that of the call center. There are certain research work has been found that in the call center workers, this alcoholism and drug dependency is very high. These are definitely not not generalized condition, but in some research it has been. So these are the major causes of sickness absenteeism, and next we are going to the prevention. To prevent sickness absenteeism, the most important is the managerial aspect. Good factory management practice is all that is needed. A good man-to-man relationship is very important. Adequate replacement examination is again important. But good human relationship, as I have already told you, is very, very important. To prevent sickness absenteeism, most important is the good managerial practice. Unless and until there is a good management practice, the sickness absenteeism can never be prevented. Because it is having a sickness factor, and that is having some factors which is not related to sickness. Both these factors with good managerial practice can be addressed. An application of ergonomics, we have told in my first discussion that application of ergonomics can help to prevent certain conditions, particularly during different musculoskeletal problem. Ergonomics can prevent it, and this ergonomics application of ergonomics, if it is applied properly, as they have prevent those conditions, definitely the sickness absenteeism decreases. But again, I am telling you, it is a good managerial practice, good human relationship. That's the only thing that can lead to the proper prevention of sickness. So, with this, I come to the end of today's session, and and I am open for discussion.
Thank you, Dr. Park. Any comments from the participant? Any participants? Any comments? To me, this is a very wonderful lecture, because we have certain types of the area, and in that area, I mean, people say the engineers are the masters, but this is the totally area which are being unexplored by us. So naturally, we got many new thought currents from you. So thank you, Dr. Bach. Any students or the participants wanted to put any interaction, because today is sir's last day. I mean, Then again in the next program, again you will see him. Well, in this year's, this particular program, it is the last, opportunity for you. Okay. Anyway, so Sarah will also put forward some MCQ, so that you will.
Okay, I'll send you
Yes.
across.
Yes, yes, yes.
Okay.
So
Thank
thank you,
you.
Dr. Abad.
Thank you.
So I am ending the session. Actually, I have to join another corporate meeting. So I was about to tell our Paumi to conduct, and I already sent you the WhatsApp that I have to join another corporate meeting to carry out the proceedings. But it is all right. Everything is managed. So timely you managed, but every our level the knowledge of thirst. So that is being quenched. So that is a great thing. Thank you very much. We are leading the meeting. Okay. Please.